AI can build software faster than ever. It can create a page, change a workflow, draft code, explain an error, and help you move from an idea to something real far more quicker than before. But there is a risk hiding inside that speed. Yes, AI can make a change, but it cannot carry the responsibility when that change breaks a stable part of your product. That responsibility still sits with the person building the system. And that is why so many AI-assisted builds become fragile. And it's not always because the prompt was bad. It's because there was no control system around the prompt. You may recognize this. You ask an AI to fix one small issue, and it ends up changing more than you asked for. So now, you're not just dealing with the original issue, you're aiming to work out what else changed, which layer actually failed, and whether the apparent fix has created a regression somewhere else. Maybe the problem looks like a back-end failure. Maybe it is actually a response shape issue in the interface. Or maybe the AI changed a stable component because nobody defined the scope clearly enough. And the result is usually the same. Progress feels fast at first, then the product becomes harder to trust. And I'm not here saying we should avoid using AI. I'm not saying that in no way at all. But what I am saying is that we need a better operating method for using it. That method is called, and what I also call, loop engineering. Loop engineering is the practice of using a human-controlled loop between AI systems, live documentation, architecture, execution, testing, auditing, and approval to produce reliable outcomes. So, in plain English, AI can help with the work, but the human remains responsible for the system around the work. The human decides what the real problem is. The human decides which information is trusted. The human decides what can change, what must stay frozen, what evidence is good enough, and what test proves the work is complete. That is the difference between simply asking an AI to do something and using AI inside a dependable building process. Prompt engineering asks, what instruction should I give the model? Loop engineering asks, what needs to be true before I accept the result? The loop has 7 parts to it. First, we want to capture the real problem, constraint, or build event. Then ground the work in the right documentation, architecture, notes, product rules, and current evidence. Then diagnose the first broken contract, not the loudest symptom, the first place where expected behavior and actual behavior diverge. Then design the narrowest safe action. then execute within that scope. Then verify the exact path that failed, along with the neighboring paths that could now be at risk. Yeah? And finally, we learn. Yeah, we always record what happened, what evidence changed the decision, and what rule should guide the next build. Like, this is not about slowing down AI for the sake of it. It's about making the speed safer. So here is the core idea. A prompt is an instruction. It is not an operating system. A prompt tells an AI what you want it to do. An operating system decides what context is trusted, what the AI is allowed to touch, what must be reviewed, what proof is required, and who has approval authority. That is the major difference. So a prompt-centered workflow often optimizes for immediate output. But a loop engineering workflow optimizes for reliable outcomes over time. The model's output is not the finished product. It is an input to the human judgment. Let me make this practical with an illustrative example. A user completes an action in your product. The expected outcome is simple. The browser sends the correct information. The backend processes that information, yeah? The backend returns a valid response. The interface shows the user a success state. But instead, the user sees a blank screen. Now, an impatient response would be to start changing the backend permissions, database or schema. That may feel productive at first, but we have to remember it is still just a guess. So what I feel would be a better approach is to trace the smallest path. What did the browser actually send? What did the backend actually return? And how did the interface interpret that response? Imagine the browser payload was correct. Imagine the backend response was also correct. But the interface expected one response shape and received another. Perhaps it expected an object, but the response was nested differently. The blank screen is the visible symptom, but the first broken contract is the interface interpretation. That changes the decision completely. You do not need a broad rewrite. You need a narrow correction in the layer that first failed. And then you test the original path again, plus the nearest realistic regression paths. Before you let AI patch anything important, prove three things. First, prove the payload. What did the browser or client actually send? Second, prove the response. What did the backend or service actually return? Thirdly, prove the interpretation. What did the interface do with that response? So once you know where the first divergence happened, patch only the layer that owns that failure. Do not change permission because a route redirected unless you can prove permissions caused the redirect. Do not change a schema because a screen, looks wrong unless you can prove the data model is the first broken contract. Do not rewrite stable areas simply because a broad change looks clearer. The smallest evidence-backed patch is often the safest one. AI can help you draft, build, analyze, refactor, and move faster. But humans must still own purpose, scope, evidence, risk, approval, and final judgment. This is not a limitation of AI. That is responsible system design. Loop engineering is not about making AI less useful. It's about making AI-assisted work more trustworthy, repeatable, and commercially useful. So, over the next videos, I will break down through real operating methods, practical frameworks, sanitized build stories, and simple rules you can use in your own work. The goal is not to build with AI and hope. The goal is to build with leverage while keeping control. So, build with leverage, keep control. This is loop engineering.